Okay, if you say so.
All right, there are two types of angle pairs that we're going to talk about today: vertical angles and angle bisectors. So first thing we'll start out with are vertical angles. Vertical angles are angles that are formed by crisscrossing lines. If you see an X, it's going to be like your big red flag that they're vertical angles. Vertical angles are things that just like they never, ever, ever, ever go away. They'll pop up now, later on. They just keep popping up. So the only way you know pretty much that you have vertical angles is if you have crisscrossing lines. This is in section 1.7. We skipped all of the word. If you look, like the rest of the stuff in between is all word stuff. We're skipping that this year. But vertical angles are angles that are back to back. So see here how you have 1, 2, 3, 4 little like corners or angles here. This angle 1 and this angle 2, they are vertical angles. And I always think of them as back to back. They're formed by crisscrossing lines. It's good. Your red flag, like I said, is going to be when you have the X kind of going on here. So this is a pair of vertical angles. And then angle 3 and angle 4 are another pair of vertical angles. So they cannot be right next to each other. And right next to each other is considered to be adjacent. So they can't be like right next to each other or share a side. They share what's called like a vertex. So they're back to back. So these two angles are vertical, 1 and 2. These two angles are vertical, 3 and 4. So for vertical angles, because we do have some algebra coming up in the next couple of minutes here, vertical angles are congruent. Anyone remember what congruent means? Equal. Yep. So if you have vertical angles and you have to solve for something, you're going to set them equal to each other. And then solve for the variable, plug it back in if you need to, but that's what you do with vertical angles. They are congruent or they are equal to each other. That's the main thing to take away. Knowing what the angle pair is or what the name of them are. So back-to-back angles are vertical angles. And we know that they are equal to each other. So like if angle 1 here is 60 degrees, we know that angle 2 is also 60 degrees. We use vertical angles a lot when we get into parallel lines and finding those angle measures because they're the easiest to kind of spot because of the crisscrossing or the X. So let's take a look at a couple of examples that we have on here first, and they're really the only examples. If we take a look up here, not really sure how that guy got up there as well. But see here how we have the crisscrossing, these two angles, these two lines are crisscrossing, and these are back to back. So these are vertical angles. If you need to solve for X, you would just set them equal to each other. So 4X equals 3X plus 35. And then you would use your awesome algebra skills. How would you solve this one? So we set them equal. We have 4x equals 3x plus 35. It's really one step. Yes?
Subtract 3x from 4x.
Perfect. Subtract the 3x. And you get 4 minus 3 is 1x equals 35. And if you had to, you could plug it back in and find the angle measures. We're not going to do that here in the notes, but you might have to do it today on your assignment. But for the most part, just make sure you set them equal to each other. And that's really all there is about vertical angles. So angles that are back to back. So like these two would be equal. These two right here would also be equal to each other. They're not, nothing's labeled there, but those would also be equal. Lots of equal stuff today. The other angle pair that we're going to talk about today are angle bisectors. And we're actually going to use this little area right here in your notes. Maybe that's why we did it. And we're going to talk about an angle bisector. some reason it didn't pop up in the notes. Not sure where it went. So an angle bisector is kind of like the midpoint of a segment, but it's on an angle. And what the midpoint did when we learned about that is it cut your segment into two equal pieces. And that's what an angle bisector does as well. So if you have an angle, so we have one ray coming out right here, one ray coming out right here. And then if you have another ray come from the center, if I'm going to call this right here the angle bisector, what this is doing is it's cutting the angle into two equal pieces. So this piece and this piece are equal to each other. When you are showing that you have equal angles, you use the same number of little arcs there. I think some people tried to do this on their quiz. I think there was an angle and you had to solve for X, and some people just took the number and divided by 2. That only works if you know that it's an angle bisector. So, for instance, if this is A, B, C, D, if angle ABC is, we'll say 100 degrees, that means that each one of these little angles, angle ABD is 50, and angle CBD is also 50 degrees. That only works, you can only do the divide by 2 if it's an angle bisector. You've got to look for either the markings, they'll put the little arcs there, or they'll actually use the words angle bisector. So it's kind of the same thing like with the midpoint. You can't assume that you have a midpoint unless you have the little dashes or they say the word this is a midpoint. So if you take a look at our little examples here, no, that's all we have for examples on there. This is an example of an angle bisector because we have arc. So this is an angle bisector. And you are going to have to name these angle pairs as well, so we may as well get used to it. If this is an angle bisector and say we want to solve for X, how would we solve for X? On this one, what would we do? Go ahead, Sam.
Set 26 and 5x plus 11 equal each other.
Take 26, set it equal to 5x plus 11. Today, basically everything's equal to each other. Tomorrow, it takes a little bit of a turn, so enjoy today a little bit. So if you have 26 equals 5x plus 11, draw my little line down, subtract 11. 26 minus 11 is 15. And then divide by 5, x equals 3. And then if we had to, we could plug it back in, but we don't have to because we don't really need to, because if this is 26, we already know that's 26. How would we do the next one? If we have this situation going on here, how would we do this? There's a couple of different ways you could do this. What's one way you could do it? If I wanted to solve for x. Knowing that this is an angle bisector because they have the same arches or little arcs there. How could we do this? Anybody? Divide 150 by 2, which gives you 75. Okay, what do I do with that 75 now? Yes, Lauren.
Wouldn't that mean that 4x minus 5 is 75?
Yes, if this is 75 degrees and this is 75 degrees, to solve for x, you would take 4x minus 5 and set it equal to 75 degrees. Then you'd use your awesome algebra skills. Add 5 to both sides. 4x equals 80. And then divide by 4. And you'd get x equal 20. That one made you work a little bit for it. That might be like the hardest problem you do today, right there. All right, down below here, you have some vertical angles I want you to try on your own. Solve for x. All right, so what type of angle pair is this one right here? What do we call these? Vertical. So these are vertical angles. You know they're vertical because they are crisscrossed and they're back to back. So vertical angles are equal to each other. So to solve for x, you should have set them equal to each other. And then solved. So subtract x. 16 equals 3x minus 5. Add 5. 21 equals 3x. And then divide by 3. And you get x to equal 7. Yeah.
In my experience, I usually do this for both sides. I just choose the one that isn't a decimal. Is this possible for that, or are both of them going to equal numbers, and I just have to figure out which one is correct?
What do you mean decimals?
Basically, if I were to do this same process but for both sides, and if it's hard to basically, I do the same process that we did for this, except instead of doing it for the side that was like 16, I do it for the opposite side where like minus the x that isn't on the side of 16 stuff.
Oh, like solving it?
Basically, I do it on both sides, and whichever one is a decimal is the wrong one. Is that possible here, or would both of them equal whole numbers, and I just have to choose which one's correct?
No matter which way you solve this equation right here, you should always get a whole number. You're always going to get the same answer. It doesn't matter which way you solve it, you're still going to get the same answer as long as you solve it correctly. And a way for you to check yourself here that I would recommend, especially on a quiz or a test, is if you take the 7 and plug it in here. 7 plus 16 is 23, so that means that angle measure is 23 degrees. And then if you take the 7 and plug it in right here, 4 times 7 is 28. 28 minus 5 is also 23 degrees. So because when we plugged them in, we got them both to be equal, that's how you know that that answer is right. So my favorite part about algebra was that you really should be able to walk out of quizzes and tests knowing if you got 100% or not, if you check your work. With these angle pairs, it's kind of going to be the same idea. So Friday, when you take your quiz, if you are plugging all of these back in and they check off, that's how you kind of know you did it right, if you want to take the time to check them. This last one right here, these are also vertical angles because they're back to back. You have crisscrossing lines, so you should have set them equal to each other. Everything today will be set equal. It's kind of getting you back into the algebra groove. Tomorrow, like I said, tomorrow takes a little bit of a turn from that. So you get x equals 15. And then if you wanted to, you could plug it back in to check yourself. Any questions? That's it for today for notes. Pretty easy stuff.